through the circle question, Jan 2010 C2. It's question 8 of that, so if you want to refer to your exam papers, you'll see that question in there. There's two parts to the question, a part A worth 4 marks, a part B worth 3 marks. This is the equation of the circle. Part A is asking you to identify what the centre coordinates and what the radius of the circle is. Okay, well this is typical of the equation, standard equation of a circle, and quite often when you're given it like this, the first thing that you need to do is get it into the format that we've talked about in the past, where we've got the brackets squared. As soon as you get it into the format with the brackets squared, it's really simple to identify the centre and the radius of the circle. So okay, let's take it through. The first thing you need to do is restructure this. Get the x quantities together first, then the y's, and then take all the numbers to the other side. So I'm going to restructure it and say that leave the x squared where it is. The plus 4x I'll put down next, so you group the x quantities together. Then I'll deal with the y's. Plus y squared I'll put next, and then the minus 8y afterwards. So we group the y's next. What I'll do then is put the equals, and I'll take all the other quantities that we've got left, and it's just a plus 10, to the other side. The plus 10, take it to the other side, we make it a minus 10. Once we've got it in this format, we now take the first two terms and we're going to use the completing the square technique on the first two terms. So I'm going to say that x squared plus 4x is the same as some bracket squared, take away some number on the end. Okay, how do we find out what this expression is? Well, if that's an x squared, that must be an x. If that's a plus 4x, it must be a plus 2. Just half of the plus 4. If I just go at the side here, and I write down x plus 2 squared, that's what I've got there, putting it there, and I actually work that out. X, if you square it, you get x squared. Multiply the 2 together and double, you get plus 4x. And then square the plus 2, you get plus 4. So that thing is the same as that. In other words, that is the same as that. Well, if you compare that to what we've got above it, the x squared and the 4x, yes, that's what we've got. This thing, however, has got an extra plus 4 compared to that thing. I don't want that plus 4 present because I've only got that. So what I've got to do to that, which is that, I have now got to take away a 4 off it. If I do that, then that thing will be the same as that thing. They will be identical. And that's what we've talked about when we're doing completing the square techniques way back in September, October time. You do a similar sort of thing for the y's. Okay, so I'm going to say plus, we're going to have a bracket squared. If it's y squared minus 8y, it'll be y minus 4y. Sorry, y minus 4, not 4y. Y minus 4 inside the bracket. Minus 4 being half of the minus 8. I'm not going to do a side little calculation here, I'm just going to do it in my head here. If you square the first, you get y squared. Multiply the 2 together and double, you'll get the minus 8y. And of course, for this bracket squared, you'd also get minus 4 times minus 4, you get plus 16. We don't want that plus 16, there's no plus 16 up there, so we need to say let's get rid of that plus 16, so we take away 16. We've still got the equals, we've still got the minus 10. We've now got it in this format. We need to tidy up a little bit. We put the bracket with the x in squared first, plus we've got the bracket with the y in, like so, y minus 4, bracket squared, that comes next. And we'll take all the numbers to the right hand side. Got minus 4, minus 16, that's minus 20. Take it over, becomes a plus 20. Plus 20 with the minus 10, you get an answer of plus 10 on the right hand side. Once it's in this format, it then becomes really simple to work out what the centre and the radius of the circle is. So looking at this, the centre of the circle concerned, if that's a plus 2 in the x bracket, the x coordinate of the centre will be minus 2. If that's a minus 4 in the y bracket, then the y coordinate of the centre will be plus 4. If the 10 on the right hand side is present, it means that the radius is simply the square root of 10. That's not a nice whole number, we'll leave it in surd format, root 10. There you go, there's the centre and the radius of that circle. That's part A done. I think that's worth 4 marks. Okay, moving on quickly to part B. Part B talks about a straight line called L. And what we've got to do is prove that this straight line L is a tangent to this circle. Okay, so if I just say now part B, here's straight line L, I'll write down its equation. You're told its equation is x minus 3y plus 4 equals 0, like so. And it says show that L is a tangent to the circle for 4 marks. Sorry, part A was worth 3 marks, this is worth 4 marks. Okay, so looking at this, it's basically one fundamental principle we're dealing with here. If you have a circle, that's the equation of the circle, we've got a circle, and you've got a straight line, there's the equation of the straight line. If they cross like that, then if you solve those two equations simultaneously, you'll get two distinct solutions, and they correspond to the two intersection points you can see in the picture. If, however, the straight line is a tangent, that's supposed to be touching there, is a tangent like so, then when you take the circle and the tangent equations, the straight line equations, and solve them simultaneously, there will only be one intersection point, which corresponds to that point there. So in this situation, if we're asked to prove that the circle and the straight line are, the line is a tangent to the circle, then very simply all we're going to do is take these two equations, solve them simultaneously, and there should be one answer coming out from this. Here we go then. I'm going to call that equation 1, I'm going to call that equation 2, and I'm going to solve 1 and 2 simultaneously using our techniques from September, October time, off the C1 paper. Okay, well number 2 is the linear equation. So I'm going to take equation 2 and I'm going to restructure it. I'm going to get x on its own because it's got a nice single x. That would make more sense to get the x on its own as opposed to the y, which is 3y. So I'm going to leave the x on the left. I'm going to take the 3y to the other side to make it plus 3y. I'm going to take the plus 4 to the other side to make it a minus 4. So x equals 3y minus 4 from equation 2. I'm going to call that the asterisk line. And all I'm going to do now is substitute that asterisk line into equation 1, which is the circle equation. So equation 1 now becomes the following. Everywhere I see an x, I change it to 3y minus 4 in equation 1. So x squared, you're going to get, instead of x squared, you're going to get 3y minus 4 squared. So 3y minus 4 squared. Plus y squared, leave that alone, don't touch it. Plus 4x's, so that's plus 4 lots of x, which is 3y minus 4. Like so. Now, I'm going to run into these pictures here, so I'll make some space. Get rid of them. So I've done plus 4x's, there it is, plus 4 lots of the x. Take away 8y, leave that alone, don't change that. Plus 10, and it's equal to 0. So there you go. We now have an equation coming out. It's only got the variable y in it. That's the unknown quantity y. So we can solve this. To solve this, what you're going to have to do is expand these brackets out for this equation. So expanding this out, square the first, you're going to get 9y squareds. Multiply the two together, you get minus 12y. Double that, you get minus 24y. Square the minus 4, you get plus 16. You've still got the plus y squared, that hasn't moved anywhere. Expand this bracket out. Plus 4 times 3y, you get plus 12y. Plus 4 times minus 4, you get minus 16. Minus 8y plus 10 remain present in their current positions. Equals 0 stays the same. Let's just tidy things up. 9y squared plus another y squared, you've got 10y squareds. Minus 24 plus 12y is minus 12y. Minus 12y minus 8y is minus 20y. Then we've got numbers to collect together. I've got a plus 16 there, which actually, if you look, will cancel with the minus 16, so they disappear. And the only other number I've got is plus 10. So plus 10 goes straight down. Equals 0. So there you go. We've got a quadratic equation. It's in the right format. We've got 0 on the right hand side. Okay, before I try and factorise this, I would suggest you make your life a lot easier by realising you can share every term by 10. So if I share by 10, you're going to get a single y squared minus 2y's plus 1 is equal to 0. Now we can try and factorise. It's a lot easier. In these questions, it is highly, highly unlikely that you'll ever get a quadratic formula having to be used. They're going to factorise, as is the case here. You're going to get 2 brackets equals 0. Well, if it's y squared, it must be y and y. If it's a plus 1 on the end, I suggest it's going to be 1 and 1. Looking at the fact we've got a minus 2y in the middle, it must mean that we've got 2 minuses there. If you were to expand out that double bracket, you would get the line above. So that's the factorised format. Good news! You can see that the 2 brackets here are identical, which means even though it's a quadratic, which gives 2 solutions, we only actually get 1 distinct answer, which of course therefore means that the straight line, referring back to the picture I rubbed out, actually is a tangent. There's only 1 contact point. Okay, so let's have a look at this. So therefore, y minus 1 equals 0, y equals 1, and if you want to do it twice to demonstrate the fact that you get 2 identical, I hope you can just see that at the bottom of the screen there, you get 2 identical answers. So what you need to do then is simply write a conclusion. You need to say in your notes, I'm not going to write it down, you can write it for yourself, therefore you get 1 distinct solution for the intersection point. Therefore the straight line must be a tangent. And if you want to do a little sketch for the examiner showing the circle and the 1 intersection point to demonstrate the point that the tangent only touches in 1 place, that would be good as well. Notice that I haven't worked out the x coordinates. There is no need to do that. It doesn't say work out the actual coordinates of intersection, so I don't need the x coordinates. I've just demonstrated the 2 y values are the same, therefore there's only 1 distinct point, which is an intersection point, therefore the tangent exists as we were required to prove. There you go, that's the end of the question.